Andrew Boyle of General Dynamics. Can you tell me a little bit about your company and the products it produces?
General Dynamics UK is the UK wing of the General Dynamics Corporation out of the US. We're based in South Wales and on the south coast of England in Hastings. We employ 1,700 people and we make a number of products for the British Army and overseas customers. The main product we're talking about today is Scout, which is behind me, and it is a vehicle that is part of the specialist vehicle family that will be delivered to the Army over the next 10 years.
Can you tell me a little bit more about that product and any particular improvements you've made to it?
What you see behind me is a prototype of the Scout reconnaissance vehicle of the specialist vehicle family. It is an upgrade of the Ascot platform, which is in use by the Austrian and the Spanish armies. But we have developed the vehicle for the British Army. They had particular requirements on safety, on internal space, and on bringing communications and reconnaissance capability into the platform that hasn't existed before.
Martin O'Neill of BAE Systems. Can you tell me a little bit more about the Scimitar 2 and any particular improvements that have been made to this product?
Scimitar 2 comprises of a brand new hull. The UOR is about mine blast predominantly. So we've produced a new hull made from a new material. We've looked at the internals of the vehicle and changed those. We've got mine blast attenuated seating. We've taken into consideration secondary projectiles. So the vehicle has been designed at BAE Systems Telford. It's been produced at BAE Systems in Wolverhampton. They fabricated the aluminium hull. The hull is then produced and sent across to DSG Donington, and that's when they integrate the rest of the systems to the vehicle to build the whole vehicle back up. The manufacturing time is approximately 3 months from start to finish for each platform, and currently we have 18 vehicles deployed on operations with the British Army in Afghanistan.
Will Jimson of Cambry Wiring Systems. Can you tell me a little bit about your company and the products it produces?
Cambry Wiring Systems is a leading British international provider of electrical harnessing interconnect solutions and services to the aerospace and defence markets. Traditionally, our pedigree comes from our involvement on the Nimrod, Typhoon and Tornado projects. But today we deliver global solutions to the AW101 project, to the C-130, to the C-27 in the defence side, and in the civil aerospace business we're providing harnessing on the Boeing 787 Dreamliner project and various Gulfstream platforms. We're based in Swindon, where we have 60,000 square feet of manufacturing facility where we employ over 200 people.
Cobham is a company that's been going now for over 75 years. It's got product portfolio that pretty much sits on the aerospace sector, land, defence, marine and also into the space sector. So it's got a very wide product portfolio. The business unit that I represent manufactures vehicle communication systems for main battle tanks and armoured personnel carriers. So we've completely redesigned the product and it's currently going through full environmental trials, and basically we are manufacturing the product to IPC 610, which is a manufacturing standard in electronics. There's 3 classes of manufacturing standards within that specification. There's commercial grade, medical and then military. And because of the environments within the military sector, it's the very highest quality standard within that specification.
Yes, the product we can see behind us is our FOFI or fibre optic front end that has been developed specifically for the Eurofighter Typhoon, which relies on fly-by-light, and it supplies and receives signals along the optical data bus that's throughout the airframe. The technology is based on thick film, and we start off with a ceramic substrate to which we add precious metal interconnect by a screen printing process. And this process has been developed over time to allow us to perform a technology transfer to higher temperature applications, which are being demanded more and more by markets such as the oil and gas industry. And this is where they need to drill deeper into the ground, where temperatures get hotter and the lifetime of electronic systems become reduced. So our ceramic technology, being an inorganic material, survives much longer at higher temperatures and provides a cost reduction to those who design and manufacture drilling tools for that particular application.
I work for Thales Optronics in Glasgow. We specialise in the design and manufacture of optronic equipment, which is essentially day and night vision equipment, such as this laser designator and thermal surveillance camera. We've been in the optronics business for over 120 years. In Glasgow we have over 700 employees specialising in the design and manufacture of the day and night vision equipment. We've been manufacturing laser designators like this for almost 50 years, thermal surveillance cameras for over 35 years. We're a major supplier to the UK MOD and many overseas customers. This camera here is just shortly to go into production. It follows on from its predecessor, which we supplied to the UK MOD. One of the things we took into account during the design of the camera were comments from our customers. They wanted the product smaller, lighter, easier to use, and of course more affordable.